All right, so now what we're going to do again here is we're going to introduce the concept of database design. Now, there's three phases to the database design methodology that we'll talk about. Three main phases: conceptual, logical, and physical. Each of these has their own starting points and endpoints, and how we move from one to the next. All right. So the idea is that we don't want to just ad hoc this thing, and there's a process, the development process that we call ad hoc. Ad hoc is usually how most first-year programming students and even some older ones develop their software, where we say, oh, this is the requirements. Let me sit down and start typing code and compile it and run it. And if it doesn't work, I'll try to figure out what's going on and try to, figure out the problems. As you can imagine, an ad hoc approach often results in really, bad problems later on, right? So what we're going to do is we're going to have a structured approach, a systematic approach for how to start from an empty, start from no database, or maybe an existing database structure, whatever, and we're going to design, we're going to take all of our different parts of what we're trying to create, and we're going to design it systematically and document along the way, so that we have a good idea of how it was designed and how it was developed. Okay. Our three main phases that we will move through will be conceptual, logical, and then physical. Right? And as you can imagine, that once we get through with the physical database design, the ultimate goal, what we'll have at the end of that, will be an actual workable database, right? So once we have that physical database design done, then we can buy servers, we can install database software, we can start, adding rows, creating tables, adding rows, all right, all that, right? Up until we get done with the physical database design, we don't have a database working yet. Right. All of this is designing this along the way so that when we get to this final phase, once we get to this last step, anyone can take what we've done so far and create their own database to match what we've done. Okay. One of the things that we're going to be doing along the way is we're going to be we're going to have a model centered approach. So for example, the conceptual database design, the output of the conceptual database design will be an ER diagram. So we will have a model of our database, the idea of our database, as the output of the conceptual database design. Then what we'll do is we'll take that ER model and we will put it into our logical database design process, and we will start constructing a different type of model. Okay, but now we're still at the end of the logical database design. We will not have we won't have a particular DBMS. Like, we're not going to say we know that it'll be Oracle or we'll know it'll be MySQL or anything like that. All right, but we're still independent of a particular DBMS. Someone could take the output of our logical database design and put it into an Oracle database, put it into a MySQL database. Logical database design, we are still not we still have not chosen a DBMS at this point. Okay, but once we get out of this, we'll have our data dictionary. Out of that, we will have we will begin the physical database design process. At this point, we will start talking about how to do indexes and how we can create base relations or tables, how file organizations should be done to make sure that the data can be accessed efficiently and quickly. Also, we'll talk about integrity constraints here, and this is when we'll start discussing which DBMS should we use? All right, because there will be some times where we'll say, well, we need to be able to have access to this type of integrity constraint. We'll have to have access to this type of security. We'll have to have access to this type of index that we can create. And there will be some DBMSs that will allow for those things. But as we've learned with MySQL, for example, the check constraint is not implemented by MySQL, right? And so we may not be able to use MySQL if certain things are required. Okay. All right. Some critical success factors. What we'll have to do. We need to work interactively with the users. Now, again, as you've probably experienced in your own life, users don't know as much about the technology as you do, right? I'm sure many of you have had to walk a parent through, a mom or a dad. You've had to walk them through, how to solve a computer problem. Okay, it's like, and mom asks, how do I shut down the computer? And you say, you click the start button. And she says, what do you mean I have to click the start button? I don't want to start, I want to end. And okay, yeah, I get it. Right. But they're going to be the ones that are going to use our systems. They're going to be the ones that primarily interact with our systems more than we do. So we need to make sure that they understand how it's going to work, how it's going to be useful for them. So at the end of each phase, what we're going to do is we're going to go back to the users and the customer, and we're going to ask them, okay, this is what we've designed. Does this look good to you? Does this look like this will work? All right. And when they sign off on it, then we can move on to the next phase. Okay. We're going to follow a structured methodology. We're going to not do this ad hoc again. Let's see. One thing else, we're going to use diagrams to represent as much as possible. Diagrams are very helpful for both us as the technical folks on the side of this, as well as the users who don't know as much of the technical aspects of this. Diagrams are very useful to help us all understand the system. And one thing we have to be willing to do is repeat steps. If we get to the end of a phase, if we get to the end of a particular part, and we realize that we've done something that the user doesn't like or doesn't sign off on or doesn't agree with, we need to be able to go back and repeat to be able to understand, to be able to produce what is really going to be useful for them. All right, let's see, question. Oh, is my microphone is on. Am I having issues with the microphone? Okay, good. All right, so hopefully it's recording. Hopefully it's recording. All right. Where am I? Here. Okay. So we're just going to overview a little bit of all the methodologies of all the database designs, and then we'll go down into them more in more detail in the coming weeks. Okay, so today we're just going to overview all of the design methodologies, all the design phases, and then we'll get them in more detail in future weeks. Okay, so the conceptual database design, we're going to exist of 9 main steps. And again, what we're going to do is at the end of the conceptual design phase, we will have an ER model that the user agrees with, that the user agrees that works. Okay, that's something that we understand, something that they understand, and so the output of this is an ER model that represents our system. Okay. Then we'll move on into the logical design phase, where we will create a logical data model. So the input to this is an ER model. So basically, if we created an ER model out of the conceptual phase and we didn't do anything else with it, we should be able to give our ER model to another team somewhere else, and they should be able to then build the logical data model off of that. Okay. We'll talk about during this phase, this would be when we might merge a logical model into a global model. So what often happens with really large systems is you might have one team that is in charge of one part of the system and another team that's in charge of another part of the system. There will be some overlap between those two, so there will be some merging to be able to have them work together. Okay, so let's say, for example, in a university system like here, like at Octonese, you might have a team that was in charge of the student side of things, the student interaction with a system, and you might have another user another team that's in charge of the teachers side of things. Right? Now there is some overlap, right? Teachers and students both interact with courses, right? So assuming that both teams created models representing the course, right? The course part of the system, and the team that was in charge of the teachers, they also modeled the course aspect of the system. They might not have done everything the same way, right? But they need to work together because it needs to be one overall system. And so we're going to have to merge that together. Okay. Again, we're going to review this with the user, and then we're going to move on into the physical. Physical has a lot to it, right? We're going to design our actual base relations. We're going to talk about what's called derived data. We're going to talk about file organizations and indexes and how different DBMSs allow or don't allow for these things. We're going to design user views. So how our particular user is going to do this. Security will come into place. We haven't done security yet, right? We haven't done security because the conceptual and logical phase doesn't care about security. It only cares about the functionality of the system and how it's going to operate, right? Here, once we get to the physical considerations, that's when the security becomes a factor. Okay. Control redundancy and monitor and tune the system. This is where your database administrator will be very important. Okay. The database administrator will monitor and tune the system. Okay. He or she is going to be in charge of making sure that everything runs very, very smoothly. Okay. All right. So that's an overview. Right. So I don't want to get into the conceptual model too much today because I did just share these slides with you yesterday, I think. And so but I do want you to at least look through this in preparation for the future. Okay. That as we build our conceptual data model, as we start to understand entity types and relationship types and what attributes is, we will need to be able to identify what entities are we going to track, what attributes are there going to be for those entities, how are the different entities going to interact with each other, what relationships will they have, right? What are some of the restrictions on those attributes? Right, so this is where we just start to kind of analyze. This is where we're going to use. Those fact-finding techniques that we've talked about previously. We're going to take those, the analysis of the system, and we're going to start trying to understand what are some of the components of our system at a high level view so that we can build our ER diagram out of that. Okay. All right. So we won't get into that today. And again, we're ending here quite a bit early. and I'm hoping that's okay with you guys. What we'll do is, starting next week, we will talk about these different design phases. Okay, so Monday afternoon, we will talk about the conceptual phase, and then we will move into the logical and physical as well. So over the course of the next week, and then after the midterm, we'll finish up. Okay. All right. So we'll end there for today. Like I said, quite a bit early. And unless there are any other questions, and you know, hopefully the recording has been recording my microphone here, and that Tirana and anyone else that might have had some audio difficulties will be able to hear it on the recording, on the video. All right. Okay, guys. Well, have a good afternoon, and I hope you have a good holiday on Friday. Yerimi uch Nissan, right? So enjoy the Friday off. And I'll see you guys on Monday.